Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 class. Today we are going to start radicals. Okay, we're going to break up radicals into a few different parts. It's not in your book, but it is extremely important, not only for algebra and algebra 2 and trigonometry, but a lot of radical work will be done in geometry as well, which is your next class. So give me 1 second. I'm so sorry. Okay, sorry about that. So like I said, today we will be learning how to simplify radicals. And before we move forward, let's go back in time a little bit, okay? Because radicals are more than square roots, but we're going to start at the beginning so you can try to understand exactly what radicals do. When I say 5 squared, please remember that 5 is the base and 2 is the exponent, okay? That's the power. What that tells you is, hey, I'm going to multiply 5 by itself that many times. So 5 times 5 is 25. That's why 5 squared is 25. So that means that 5 is a square root of 25. If you remember from solving quadratic formula, we have to simplify radicals, right? Well, if you remember the square root of 25, that breaks down into a 5 and a 5. You circle the primes, and remember what I told you. Every pair comes out as 1 of that value. So a 5 and a 5 comes out as a 5, and that's why 5 is a square root of 25. Okay? Now, some of you may be saying, whoa, Mr. Morrow, you were very specific with us, and you told us that it's plus or minus. Why are you just putting plus now? Here's why. When you are solving an equation, you have to have all possibilities. But when you are just simplifying, they're going to let you know if it's plus or minus, if it's just positive root, or if they want the negative root. So I'll get into why and when we do things and why. So again, 6 squared is 36. The square root of 36 is 6 because 36 breaks down into a 6 and a 6. Can I break that down into a 2 and a 3 and a 2 and a 3? Yes, but why would I? As soon as you see one pair, I don't care how large it is or how small it is. As soon as you see one pair, a pair of the same value comes out as 1 of that value. Okay? And then 12 squared is 144, so that means 12 is a square root of 144. Why? Because 144 is 12 times 12. Can I break that down and take every single pair and multiply them out? Yes. But why would you? As soon as you see a pair of the same value, pull it out as 1 of that value. Now, like I said, my friends, if I said to you, x squared equals 25, you take the square root of both sides, the square root cancels the power, x will equal plus or minus 5 because it's an equation. You don't know which one was used. Either positive 5 times positive 5 gave you the 25, or negative 5 times negative 5 gave you the 25. So when you have an equation, you must express the answer in plus or minus. Okay? When you are simplifying, though, square roots, if you see a plus or minus in front of the radical, then they want both roots. So for example, if I say to you simplify plus or minus square root of 49, that equals plus or minus 7. Why? Because they wanted both roots. If I simply want the positive root, sometimes that's called the principal root or principal nth root. Nth would be representative of the index, which we'll talk about in a second. And its symbol would be just square root of a value. There's no plus in front of it. There's no minus in front of it. That just represents positive. The positive sign is assumed. It's invisible. So if I gave you square root of 49, that would just equal 7. Why? Because they wanted the positive or principal root. The negative root is its opposite, or negative square root of a value. So if I said to you negative square root of 49, that means I want the negative root, so that would be negative 7. Yes, sir. Okay, thank you. Does that make sense so far, guys? Now, as far as radicals are concerned, guys, I know that most of us have worked with square roots, and that's awesome. And a square root is very, very, very important. But radicals in general are more than just square roots. So I really need you to really understand what's going on here. When I'm given a radical, okay, this little n here, this little number that is above the radical sign, that is called the index. When it's a square root, the index is blank. When it's a square root, the index is blank. You're never going to see this. Never. This 2 is assumed. It's up here, it's invisible. So if you just see a radical with no index, I promise you, that means that the index is 2 when it's blank. Okay? I promise you. But if you see a number there, that is an index. What does the index tell you? Well, it's very simple. When it's a square root, it's an invisible 2, right? So I'm looking for pairs of numbers to pull one out, right? How large do you think the set is for a cubed root if there was a 3 there? Very good. I would need a set of 3 numbers to pull one value out. What if the index is 4? I would need a set of 4 of the same number to pull one out. What if I had an index of 5? I would need sets of 5 of the same number to pull one out. So this index tells you, hey dude or dudette, I need this many of the same value or variable to pull one of that value or variable out. Does that make sense?
Yes.
Promise.
Yes.
Okay, cool. The actual sign itself, the symbol here, that's called the radical sign. Okay? And the inside value here is called the radicand. So you have a radical. If it has no index, that means it's a square root. That means I need a pair of the same value to pull one out. If my index is a 3, that means it's a cubed root. That means I need 3 of the same value to pull one out. If I have a 4, that means it's a quartic root or a 4th root. So that means I need 4 of the same value to pull one out, etc., etc., etc. The sign itself is the radical sign. The number that tells you how many numbers in each set are required is called the index, and the inside number is called the radicand. We're all good? Yes, sir? If I have a 4 as the index, yes. If I had a 4th root of 16, okay, this breaks down into 2 times 8. 8 breaks down into 2 times 4, and 4 breaks down into 2 times 2. Sorry, it's a little messy here. So I'm looking for 4 of the same value. So I've got a 2 and a 2 and a 2 and a 2. I got 4 2s, so I pull out 1 2. Does that make sense, my brother? Thank you so much for that question. Excellent question. Now, a simplified radical, my friends, must have a simplified radicand. The inside has to be simplified. What does that mean? All sets of numbers that get pulled out according to the index, they must all be pulled out. You can have no other sets of values that you can pull out of the radicand. It has to be completely simplified. Okay? If the index is even, then the radicand must be positive. Remember how we talked about if you had this as an answer, that was a no solution? If you have an even index, so if it's blank, or it's 4, or it's 6, or it's 8, or it's 12, or it's 22, if it's an even index, you cannot have a negative radicand. You cannot. If the index is odd, it could be positive or negative. Why? What's negative 1 times negative 1? Times another negative 1? Negative 1. So 3 negatives will give me a negative. So I can have only positive radicands for an even root, but I can have positive or negative radicands for an odd root. Yes, if I told you solve or simplify square root of negative 12, that would be no solution. You can't simplify that. Number 2, you cannot have any fractions inside of the radicand. Okay? We're going to talk about why in a little bit. You cannot have any fractions. You're going to have to break those down. And 3, you can have no radicals in the denominator. And I'm going to show you also how and why that works. Okay? So let's get to it. Before we simplify, you need to know the multiplication property of square roots, of radicals, really. When I have, please pay attention, the same exact index multiplied to the same exact index, you keep the same index and you multiply the radicands. For example, the cube root of 5 times the cube root of 4 equals the cube root of 20. You can't simplify it. That's 4 times 5, which is a 2 and a 2 and a 5. Do I have any sets of 3? So I can't pull anything out. So it's simplified. Can I pull any values of 3 out of here? Can I pull any sets of 3? This breaks down into 5 times 2 times 2. Do I have a set of 3 of the same value? Someone said yes. I do not have the set 3 of the same value. So can I pull anything out of here? So it's simplified. Yes, sir. I'm sorry? No, if the indexes are different, you cannot multiply them. That's why I said you must have the same index in order to multiply them. If they give you square root of 2 times the cube root of 5, you cannot do anything with that. You're out of luck, Chuck. They do not have the same index. Sir, you would just leave it like that. Yes, because you can't do anything. In order to multiply radical expressions, they must have the same index, boys and ladies out there in the internet world. They have to have the same index. They must. If not, you cannot multiply them together. Okay? For example, let's find each product. Square root of 14 times square root of 3, same index, square root of 42. Let's see if we can simplify that. That's 6 times 7, 2 times 3. Do I have a pair of values that I can take out? So this is simply square root of 42. I'm done. I cannot simplify that. Yes, the index is 2. Yes, so do I have a pair? Do I have 2 2s? Do I have 2 3s? Do I have 2 7s? So do I have a pair of the same value that I can pull out? So it is just 42. How about square root of 7 times square root of 5? What's that? Square root of 35. It does not equal 35, guys. If you put square root of 5 times square root of 7 equals 35, that will be wrong. It does not equal 35. It equals square root of 35. And since this just breaks down into 5 times 7, I cannot break that down. Okay, how about here? Have the same index. So square root of 5 times 6 is 30. X to the 6th. Thank you. Thank you very much. Because when you multiply the same base, you add the exponents. Very well done. You just made my day. And y to the excellent. Now, we can reduce. We can not reduce. I'm sorry. That was a wrong term. We can simplify. What's the index here? 2, right? When you are simplifying variables, so easy, guys. Simply take the index and divide the given exponent by the index. How many times can 2 go into 6 evenly? So I have x cubed. Do I have any x's left over? No, right? Because 2 times 3 is 6. How many times can 2 go into 7 evenly? No, 3 times, and what's left over? Huh? 1y. That's it. What, guys, if I take 7 divided by 2, doesn't that give me, let me do it the long way so you could see it. Don't I have 1 remainder? So that means I took 3 sets of 2 out, and I had 1 left over. That makes sense? Awesome. How about for D? I had the square root, same index. 3 times 7 is 21. X to the, and y to the, k. How many times can 2 go into x to the 4th? So I take out x squared. Do I have any remainders? No. How many times can 2 go into 5? Do I have any remainders? So I got to put that remainder inside of the radical. Talk to me, guys. Some of you looked a little confused. I want to help you. Please, that's my job. That is my duty. Talk to me. Sir, thank you. We're going to have a lot of examples. Okay? But how about this? Square root of 80, x to the 9th, y to the 10th, z to the 7th, and w to the 17. I'm not trying to be sarcastic. I just want to really show you. First of all, 80. 80, believe it or not, breaks down into 16 times 5. How do I know that? Because I know my times tables. 5 is prime. 16 breaks down into 4 and 4. Wait a second. Do I have a pair already? So a 4 and a 4 comes out as 1, 1, 4. And what do I have left over already so far? Come on, guys. Think. What do I have left over? A 5. Thank you. So we're done with 80, right? We're done. How many times can 2 go into 9? And what do I have a remainder? How many times can 2 go into y to the 10th? No remainders. And how many times can, wait, let me give myself some more space, sorry. So we got 5, 1 remainder of the x, no remainders of the y. How many times can 2 go into 7? 3 with 1 remainder. And how many times can 2 go into w? 8 with 1 remainder. Does that make sense, sir? You good, my brother? Thank you for asking, son. Okay, let's move on. Now, simplifying square roots is very easy if you know your perfect squares. So that goes back to me being a broken record. You got to know your times tables. If you know your times tables backwards and forwards from the 1 to 15, this is the easiest section in the world. I mean, like the easiest. But if you don't know them, this can become very, very difficult. Remember that a perfect square is the product that came from multiplying a number or variable times itself. Again, this is all repeat. For example, square root of 25 is 5 because 5 times 5 or 5 squared equals 25. You got to know your perfect squares. Here are the first 15 perfect squares. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. Square root of 144 is 12. Square root of 169 is 13. Square root of 196 is 14. Square root of 225 is 15. Recognizing perfect squares makes simplifying square roots easy and fun. Think about this. For anyone that was like, oh my God, how did he get 16? Oh my Lord, what did he do? It's a perfect square. And I knew that. I'm sorry? You could have done 40 and 2, but you would have spent a lot more time doing that. Because then you would have had to keep breaking that down. If you know your perfect square, right off the bat, square root of 16 is 4. So knowing your perfect squares is vital. Really, guys, it's really important. Sometimes, we already went over this, but you know me, I like to repeat things. Sometimes you have to simplify variables in the radicand, which is also very easy. Remember, all you have to do is divide the exponent of the variable by the index of the radical. The whole number comes out of the radicand as an exponent, and all remainders stay inside the radicand. So again, if I have, what about this? The cube root of x to the 7th. How many times does 3 go into 7? So x squared, and I have a cube root of x left over. Does that make sense, guys?
So the index always stays?
The index always stays because that's the index that we're working with. Thank you, sir. Yes, sir. No, there is no index of 1. If it's blank, it's a square root, sir. There is no index of 1. Okay? Thank you for asking. Okay. Let's simplify each of these bad boys. Okay. I'm going to use as many perfect squares as I can. That's what I'm with my goal. This is going to be 25 times 5. Very good, son. Guys, what's the square root of 25? So this is 5 with a square root of 5n left over. Why could I not pull out an n? Because what, guys? How many times does 2 go into 1? I can't. Good job. Good job. 5, 12. Okay, it's an even number, right? So what can I do here? Tell me. Okay, 2 and what? Not 260, guys. 256. Thank you. Okay. Is 256 by chance a perfect square? What is it? It's 16. Very good. I did not put that on the list, I know, but think about it. If the square root of 15 is 225, think 16 times 16, 6, 3, that's going to be 9, 6, 1, 6, 5, 1, 256. So if you want, write that one down because it's very popular. So since I already know that the square root of 256 is 16, this is going to be 16. I know already that I have a leftover of a 2. How many times can 2, because it's invisible, go into x to the 5th? 2 with a remainder of 1x. Excellent, fantastic. Does that make sense, boys? Okay, 80. We did this one already. That's 16 times 5. Square root of 16 is 4. I know that I have a 5 inside of here already. What is the square root of x cubed? 1x with a remainder of 1. What's the square root of y squared? 1y. No remainders. How about 200? What perfect square can I use with 200? 100. Thank you. So 100 times 2. What's the square root of 100? So that equals 10. I know that I have a square root of 2 left over. What's the square root of x to the 7th? Not 3. It's x cubed. With how many x's left over? Very good. And what's the square root of y to the 8th? Y to the 4th. Guys, be careful. I hear you guys saying 4, and I'm scared that you're going to put out a 4 as the number. Okay, so please be careful. It's not a 4. It's y to the 4th. And what I have left over, a 2 and an x. Does that make sense, gentlemen? Okay. Now, same process goes for when you're dividing, my friends. Same process. Except, now it's a division. And when you have the same index, you can divide the radicals. Now, I want to show you what this means here. If I have the square root, for example, or let's say the third root of 8 divided by the third root of 2, I can turn this into, excuse me, the cube root of 8 over 2, which is a cube root of 4. I can do that. And vice versa. I can split it up even if I can't divide it. Let me explain what the heck I mean there. Let's say I tell you you have the square root of 16 over 2, or 16 over 2. Oh, no, not that. Not that. 16 over 3. 3 does not go evenly into 16, right? But I can do this. I can make this the square root of 16 over the square root of 3. And then what does the square root of 16 equal? So that would be 4 over the square root of 3. Now, if you remember, I said this is illegal. You cannot have a radical in the denominator. No, it's not no solution. I'm going to show you how to do that in a second. So this is not the end of it, but that's what I mean by this. You can split up divisions in the same radical. Okay? So again, I have to still simplify this. It's called rationalizing, and I will show you that in a minute. So, let's try this. I have square root of 18x to the 5th divided by square root of x cubed. So this could just become one fat 18x to the 5th over 2x cubed. So that can be 9x squared, which equals, come on guys, which equals 3x. Thank you. Square root of 9 is 3. Square root of x squared, 2 goes into 2. 1 time 3x. Talk to me. Okay. Can I get my man? Okay. Here I got square root of 162y to the 5th divided by square root of 3y squared. So I can make this one big fat square root. Okay, what is 162 divided by 3? No, not 52, 54. So this is the square root of 54. And what's y to the 5th divided by y squared? Y cubed. So 54 breaks down into any perfect squares in there? Yes. 9 times 6, okay? 6 breaks down into a 2 and a 3. So what's the square root of 9? So I got a 3. Do I have any leftovers? Really? You have a square root of 6 left over. How many times can 2 go into y cubed? 1, and you have 1 left over inside the radical. Talk to me, please, guys. I got plenty of time. We got time on our side here today. I want to make sure you got this cold. We're good? Yes, sir. Thank you. It absolutely would have been wrong if you did not include this 2 times 3 inside the radical. Yes, sir. You have to put the leftovers inside. And no matter how many leftovers there are, you multiply them all together. Sir, thank you so much. Any other awesome questions like that? Sir, thank you. Yes. Let's say I give you, let's do a different root. fifth root of, let's see, of 160 x to the ninth over 5x squared. Okay? This is going to be the fifth root. What's 160 divided by 5? That's 32. Very good, son. What's x to the ninth divided by x squared? X to the seventh. Now, 32. That breaks down into 16 times 2. It's not a square root. We're dealing with a fifth root. So that's 2 times 8. So we got to break it down all the way. 2 times 4 and 2 times 2. Circle all of the prime numbers. I got a 2, a 2, a 2, a 2, and a 2. 1, 2, 3, 4, 5. So that comes out as a 2. How many times does 5 go into x to the seventh? One time with what's left over? A fifth root of x squared. Okay, you were going to say something, sir? How would I have done the square root of 16, son, if it's a fifth root? How could you have done a square root of 16 if it's a fifth root, Papo? Now, could you have broken down 16 into 4 times 4 and then 2 times 2 and 2 times 2? Of course. You could break 16 down into any way. But I don't want you to get the vocabulary wrong. No, you're not finding the square root of 16. No, this is the fifth root. Okay? Thank you so much. Does that help you, son? You sure, my man? Thank you. Okay, now, remember in the last example I said, hey, remember, you can't have a radical down here. I'm going to show you in a second what to do. Okay. Whenever you have a radical in the denominator, you must rationalize. That's what it's called. You do not put no solution. No, that's wrong. But this is illegal, mathematically speaking. If you put this as an answer, I must mark it completely wrong. Like I can't even give you a partial credit because that is mathematically illegal. So what do you do, Moro? Let me show you. Excuse me. Whenever I have a radical in the denominator, okay, I'm going to multiply the numerator and the denominator by the radical that it takes to eliminate the radical. So what am I talking about? I have a square root, right? Don't I need a set of 2 values to pull one out? So think about what I'm going to do. I'm going to multiply this by the square root of 2 over the square root of 2. 1 times the square root of 2 is the square root of 2. And guys, what's the square root of 2 times the square root of 2? Square root of 4, what's the square root of 4? No, it's not the square root of 2. No, it is not. What is the square root of 4, my brothers? 2. And that's it. You're done. How can you divide that? You cannot divide a radical and a number. That is impossible. We talked about that in quadratic formula. You cannot simplify a radical by dividing by a regular number. You can only divide the same index radical to the same index radical. You can only multiply the same index radical times the same index radical. You cannot multiply a number and a radical. 3 times square root of 2 does not equal square root of 6. No. No. Square root of 20 divided by 5 does not equal square root of 4. No, that is wrong. You cannot multiply numbers or radicals unless they have the same index. You cannot divide radicals unless they have the same index. Okay? All right, now, here, I've got 2 divided by the square root of 2 cubed x cubed. First things first, always simplify. So this is going to be 2 over. How many 2's do I have? 3. So I can pull 2 out, right? Hello? And I have what left over? 1, 2. How many x's do I have? So I can pull one set of 2 out and I have 1x left over, right?
Yes.
So what am I going to multiply to the numerator and denominator to get rid of that square root of 2x in the bottom? I'm going to multiply by square root of 2x. So this is going to give me 2 times the square root of 2x over this 2x times, what's the square root of 2x times the square root of 2x? 4x squared, which equals 2x. So this is 2 square root of 2x over 4x squared. What do you mean, what would be to the power of 2, sir? What are you talking about? Yeah, what's the square root of 2x's, though, of x squared? Guys, whenever I multiply the same exact radicals together, think about it. That equals square root of x squared. The radical and the power cancel. I'm just left with the inside. So if I multiply the square root of 3 times the square root of 3, it equals 3. If I multiply the square root of yz times the square root of yz, it equals yz. If I multiply the square root of 9 times the square root of 9, it equals 9. Because when I multiply the same square root together, I'm squaring it. And when I square root a square, don't I cancel them out? You guys with me here? You promise? Because there was a lot of mistakes in the quadratic formula, not because you couldn't set up the formula, but because you did not know how to simplify the radical. So please, please, please be careful. Let's try it. Okay, I got square root of 15 over 5 times the square root of 20. First of all, can I simplify this square root of 20 at all?
Yes.
How? 4 times 5. Very good. So this is going to be a square root of 15 over. What's the square root of 4? What's 2 times 5? 10 square root of 5. What do I have to multiply the numerator and the denominator by to get rid of that radical 5 in the bottom? Not by 5. No, not by 10 either.
Square root 5.
By the square root of 5. Very good. 5 and the square root of 5, guys, I'm not trying to be a jerk. They are different values. Square root of 15 times square root of 5, they have the same index. You can multiply them. That's the square root of 75. Over 10 times 5. What's the square root of 5 to the square root of 5? Guys, what's the square root of 5 to the square root of 5? Square root of 25, which equals 5. When you multiply the same exact square roots, you drop the square root and it's equal to the radicand. So now I can break 75 up into 25 times 3. What's the square root of 25? So 5 square root of 3 over 50, which equals square root of 3 over 10. That is my simplified radical. Does that make sense?
Yes.
Cool beans. Okay, square root of 8 over square root of 100. If you know your square roots, this is square root of 8 over 10. Thank you, son. And square root of 8 breaks down into 4 times 2. So this is 2 square root of 2 over 10, which equals square root of 2 over 5, because I reduced. How did I get this 2 on the outside, you ask? Square root of 4 is 2. Does that make sense? Okay. Square root of 6 over 27. Let's go ahead and reduce this one. Can I reduce that? Can I divide 3 to both the top and the bottom? So then I get the square root of 2 over 9, right? So wouldn't that equal the square root of 2 over 3?
Square root of 9 is 2.
Correct. Remember what we said. We can split this up into the square root of 2 over the square root of 9. And then what's the square root of 9? 3. As long as I don't have that denominator down there is a radical, as long as I don't have a radical, you're golden. How about this guy? Number 4. I got 3 square root of 20 over 2 square root of 4. What square root of 20 divided by square root of 4? Yeah, so it's 3 square root of 5 over 2. I'm done. I got no radicals in the denominator. Here, I've got a 1/4 on the outside, and I've got one big 3x squared y cubed over 5x y cubed. Let's simplify, guys. Let's make our lives easy. This is 1/4. Okay. I have 3/5, so I'm out of luck there. However, x squared at the top, x in the denominator. So I get rid of 1 here, 1 here. I'm left with an x. The y's cancel. So this gives me 1/4 times the square root of 3x over the square root of 5. I got to rationalize because I got to get rid of that denominator. So I multiply by radical 5 to both numerator and denominator, giving me square root of 15x over 4 times 5. Why? Because square root of 5 times square root of 5 is square root of 25, which equals 5. So my answer here would be the square root of 15x over 20. That 4 is from here, brother. 1/4, 1/4, 1/4. It's in the denominator. You see it? Questions, comments, concerns, problems? Okay. Let me move this over here. And let's do this last one. Okay. Here I got the square root of 15. Well, I got 1/3 over a big square root of 15 xy over 10 xy cubed. Okay. This is going to be 1/3. Take 5 away from here, making it a 2. 5 away from here, making it a 3. So I got 3 halves. The x's cancel. Take away 1y from the numerator. Take away 1y from the denominator. I got y squared left over. That breaks up into 1/3 times the square root of 3 over square root of 2y squared, which equals, hold on, this is the square root of 3 over 3y square root of 2. Notice what I did there. What's the square root of y squared? Y. That's why I put it out here. You see that? Yeah, guys, look. Square root of 2y squared. Square root of y squared is y. Now, I cannot have a radical 2 in the denominator. Very good. So I rationalize. And that's going to equal the square root of 6 over 3y times, what's the square root of 2 times the square root of 2? Square root of 4, which equals 2. So that's square root of 6 over 6y. Thank you very much. Have a wonderful day, and I hope you learned a lot. Take care.